Welcome back to PyQuick, Python class. What's the plan for this morning? So this morning I'm going to talk about regular expressions a little bit, in particular regular expressions and Python. You may or may not know regular expressions beforehand. That's OK. And I'm not going to show you all of regular expressions. I'm going to show you just enough for us to get some useful stuff done. But regular expressions are a very powerful combination with Python. There's a nice integration there, so I want to show you that. Also, the exercises later today will, of course, have little elements which are solved nicely with Python regular expressions. Just as regular expressions is sort of a good news, bad news situation. Regular expressions are very, you could use the word powerful, but I could use the word very dense. Like if you sort of measured the amount of thought and cups of coffee that get poured into per character, regular expressions are the most dense language possible. You could puzzle for hours over one line of text trying to get all the up hats and backticks and whatever correct. We're not going to get into that scary of an area, but we're going to sort of touch into a little bit of that power. So one word of warning. When messing with regular expressions, I try to move a little slowly. They're very powerful, they're a little tricky, so I'm going to try and be careful. And for today's discussion, I'm going to show you just sort of basic stuff. And if you're extremely familiar with regular expressions, well, please just bear with me for a little bit. We're not going to do this for too long. And obviously, really, I'm going to emphasize Python. That's the bad news. The good news is also on all the exercises we're going to do later today, in case I forget to mention, if there's a regular expression component, at the very end, printed in little teeny print, I put what the regular expression solution is. So it's kind of you can sort of flip to the back and get the answer if you're struggling with that part of it. Because really, it is a Python class, so I don't want you to block on the regular expressions too much. All right, so with that introduction, I'm going to start talking about how these things work. But first, I have to tell you a joke, which will appear later. What do you call a pig with 3 eyes? Pig. All right. Now that'll become the necessity of that will become clear in a little bit. So let me fire up the interpreter here. So regular expressions in Python are supported by a module called RE. So I'm just going to import that, and I'm going to do a lot of stuff here in the interpreter. I'm going to sort of build this up. So the basic idea with regular expressions is they're a way of searching for a pattern inside of a larger text. So very much like search in Microsoft Word or whatever. You have the little pattern you're looking for, and it's going to look over this huge text and find the first instance of that pattern. But it's this whole language where the patterns can be very popular. So the way this works in Python, the simplest way, is there's a function inside of RE called search. And I'll sort of spec this out. It's going to work basically this way, where the first argument to search is the pattern, which I'm going to talk about a lot. The second argument is just kind of whatever text I want to search. And what it returns is actually not a Boolean, not text, but a match object. So here I'll write this as match. And then the match object will indicate, it'll show us a bunch of things about the found text. So let me do an example. So for the text, I'll use our punchline. We'll say, it's called pig. All right, and let's say for the pattern, we're looking for, and we'll just sort of start talking about patterns here. Maybe I'll just look for IIG. This is just the simplest possible case. So, so I run it. Now it returns this match object. So if I just type match, it's not really going to print, but it'll say, well, that's that's some kind of Python object. So it turns out for the first 20 minutes this morning, the only thing you need to know about match is that it has this. It responds to this method called group. If you call group on it, it shows you here's what the matching text was. So this is our first example of a regular expression, and the simplest case in a regular expression is like the IIG here, is that a character like I or G or something like that matches itself. So the lowercase I matches the lowercase I, whatever. And then I'm going to build up the vocabulary to have a lot more complicated matches. But that's just characters matching themselves is the simplest case. All right, another thing to point out here. So this match was successful. Here I'm going to do one that's not successful. So let's say we're looking for the pattern IGS. And that pattern it just doesn't appear in there. So if I run that, and then I look at the match object, it's none. Now, in the interpreter, none just prints as nothing, but it's just not there. So if I were to try and say, oh, match.group, it's a very common error, it's not going to work, right? Because match doesn't point to an object that has a group behavior. Match just points to nothing. So the absolutely standard way to use re.search is, I'll sort of do it in the interpreter. First you do re.search, and then the next line is something like if match, like if the match is there, then we found it, we can look at the group. Otherwise, it's not there. Now what I'm going to do, I'm actually going to write, I'm going to def a little find function just here in the interpreter, just because I'm going to do so many regular expression searches today. I just want to encapsulate that behavior. So I'm going to show you here is sort of the prototypical use of re.search, and then I'll just use it for half an hour. So I'm going to say, I'm just going to call this thing find, and I'll take a pattern and some text. This is a little weird. I'm doing this in the interpreter, but this works. So I'm going to type a colon, and I hit return, and now the interpreter is saying, OK, well, what's the next line? And so I'll say, let's space, and I'll say if match. Now, I'm relying on the fact that I talked briefly about this yesterday, the rules for true and false. Now, there's a bunch of things that kind of count as false. 0 counts as false. The empty string counts as false. It happens that the value none also counts as false. So what this if statement is sort of saying is like, yeah, if that match is not none, essentially. If it's there, if the search succeeded. So if match is there, I'm going to say print match dot group. I'll hit return again, 2 spaces, and I'll say otherwise. I want to say what happens. So essentially, yeah, not found. Right? I mean, those are the 2 cases. Oops.
You always need the dot group to render
the question is, do you always need the dot group? I'm going to always use it today. In reality, the match object has. You can read the docs for it. It has to, at what character position did it start, where did it, all sorts of kind of other stuff about the match you might want to know is sort of composited in there. All right, so I'm going to hit return. All right, so now I have to find my find function. So now I can sort of use this for, well, I mean, I'll use it for my earlier example. So now if I say find on that, I get not found. And if I say, I don't know, IG, all right, why didn't that work? I didn't what?
You didn't actually do the match in your function.
Oh, I didn't do the match in the function. Oh, gosh darn it. Yeah, you're right. All right, here. I'll just do it really quickly. So there's def, and then I'll say match is equal re.search. Oh, sure, now you guys tell me. Sure, where were you 5 minutes ago? OK, so there's the match, and then I say if match colon, well, OK, everyone's going to know this code by heart. If match print match dot group else colon print not found. OK, so now, what do we say? This time for sure. Excellent, OK. So now I just want to do, I'm going to build up the vocabulary of regular expressions. So the simplest rule number 1 is that simple characters just match themselves. Rule number 2 is that, and I'm actually going to be a little high tech here. I'm going to make a little space. Special characters. I made a little table up here. The dot, very special. Dot matches any character. It means you did anything except it does not match new line. So I could have said, well, I'm looking for, let's say, any 3 characters and then a G. That's the pattern I'm looking for. And so in this case, that's going to find pig. So you get a little bit of a sense of like how this is going to be more powerful than just regular Microsoft Word search. So the another rule that's going on here is, so for example, if I were to say dot 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 G, or I don't know, X, or whatever, it's not going to find that. Or maybe I'll do the way I did it before is maybe better with the S. So if I say dot dot GS, that's not found. There's a little asymmetry here where in order to succeed, all of the pattern must match. So in this case, I've got 4 characters or whatever. I can't just say like, oh, well, 3 out of 4, whatever. No, 100% of the pattern has to be kind of consumed and matched. But that's not true about the text, right? In all of my examples, I'm not matching the whole text. Whatever, I could use a little bit of it at the end, of the start, or whatever. So that is a fundamental asymmetry. The other thing that's going to happen here is that the search is going to go left to right, and it's satisfied as soon as it finds a solution. So we could make up a case where there's maybe multiple solutions. Say for example, I'm looking for dot dot G, and then I hear like, and then I'll make this like, oh, here's a much better solution, X, Y, Z, G. And what's going to happen is, it's just not finding that second one. right? It's just not getting to it. But, well, so how could I make it find that one? Right, maybe, what if I said, well, really what I'm looking for is an X, and then 2 characters I don't know about, and then the G. So then it's like, passes over the first one and finds the second one. Now, the regular expression engine, without getting too much detail, is, I mean, it finds all the things it's supposed to, and it's smart. It understands, it'll backtrack. So for example, just as a, what if I said, well, I'm looking for ... G, and then I insist that there's an S. And here, I'll go fix this one to like have an S here. So you can imagine, so that succeeds. So you can imagine it like, it maybe sort of tries to make this one work, and it doesn't work, and so it understands, okay, well, that didn't work. It'll keep going. So the other thing it's going, it is left to right. So it finds the first one.
Can you just say that one more time, why it didn't match the first one with IIG when you...
Okay, yeah, so the question is, why didn't it match the first one? So the trick here is I added an S to the end of the pattern. If you really look at the pattern, that says any character, GS. And the problem is, it can...
That one, I mean the third to last.
This one?
One more.
One more. This one.
If
That
you
one
find
succeeded.
The second piece.
What? Oh, why didn't it find that?
It only does the first one.
Yeah.
Okay, yeah. So what it does is it goes left to right, and once it finds a solution, it's like, okay, I'm done. Whatever. It just doesn't try anymore. Yeah, question.
If you were actually looking for the period character.
Ah, yes. Okay,
you
excellent
just
question.
need to escape it with a.
Yeah. So if you were actually looking for the period character, so like let's say, I don't know, there's a dot there. What you would write is C, and you can always put a backslash in, and that inhibits the specialness of a character. So I could look for C.G, or I could look for C dot backslash dot L there. Now I'm going to introduce a slight extra bit of syntax here, which Python has, which is where it's a little troubling. Like the backslash, it could be interpreted at different levels. Like maybe Python, or like in Java, Python, or it might get taken out by the language. So without getting too much detail, I'm just going to say Python has an option called a raw string, where you put a lowercase r to the left of the leading quote. And what the lowercase r means, it says, do not do any special processing with backslashes. Whatever I type, just send it through absolutely raw and uninterpreted. This feature, I mean, it's a little bit obscure, but it happens to be very useful for writing regular expressions, because it frees us from having to worry about layers of backslash processing. So in fact, even though I've done my examples so far without the r, I'm just going to use the lowercase r for all of my examples from here on out. So I just don't have to think about it. So in this case, let's just try it. Yeah, so then it's able to find this, so it's matching that. So that's how I'm able to put the dot. But that's how I'm able to talk about a dot explicitly. All right, so what do we got so far? So it goes left to right. Dot matches any character, and all of the pattern has to be matched, but the text, we don't care. You don't have to get all the text. So let me show you some slightly more scary examples. So let's say in my text here, I've got, there's some text I don't care about, and I'm going to say, colon cat, and then there's some more text. So let's say I want to pick that part out. So the next sort of regular expression code I'm going to talk about is \w. So \w, which actually hopefully I have up here, \w matches what you would call a word character. So that means a letter or a digit, and I think it also includes underbar. So in this case, I'm going to say, well, let's say I'm looking for a colon followed by 3 word characters. So that's going to work OK. So now I could say, similar to the \w, there's \d matches a digit. So for example, if I say cat, and I'll say like colon 1, 2, 3.
I'm sorry. So what's the difference between the /w/w/w and dot dot dot?
So dot 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 is an excellent question. The question is, what's the difference between dot 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 and 3 \w's? The dot 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 just is any character. Like it could be a space, a colon, I mean, anything. The \w matches a character so long as it looks like a word character, like A through Z, 0 through 9, underbar. No, so if this was a Unicode string, the word, it's smarter about being, there is a basic notion of an alphabetic character versus essentially punctuation. Yeah, question?
You said 0 through 9, is that true? The word character?
Yeah, word character includes digits 0 through 9. So I mean, what it's a little bit like is usernames. right? Blah 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 1 2 3. The username part would be, and that'll show up in a later example. Okay, so digit is a little bit similar. Where'd my cat example go? Oh well, let's do it again. So if I were looking for, I'll have blah, colon 1 2 3, XXX, let's say. So I could look for, actually here, I'll just look for, I'm just looking for 3 digits in a row. I could write that as, oops, I'm going to put the R in also, sorry. So that pulls out the 1 2 3. Now it happens, so you can see there's sort of these different regular expression codes, \W, \D, they kind of represent sort of common cases. I'm not going to show you all of them, but I'm showing you the ones that I think are the most useful, and the ones that kind of show up in the projects we're going to do later. All right, let's say, last one I'm going to show here is white space. So suppose I'm looking for like this pattern. It's like, well, I want some digits, and they're separated by spaces. So the simplest way you do that is a \S represents a white space character. And the \S is smart that it knows about space, tab, new line. Those all count as a white space character. It knows about the whole sort of space of white space characters. So hopefully that'll work. So that finds it.
2 spaces between 1 and 2.
Yeah. So the question is, if you had 2 spaces, just hold that thought for a second, because we're about to get there. So far I haven't done any repetition. I've just had like fixed numbers of things. So probably the most powerful part of regular expressions is that there's these modifiers, plus and star. So plus to the right of something means 1 or more of that, and star means 0 or more. So really I'm just going to do that with my digits example. So the question is like, well, what if I've got these 3 digits, but well, whatever, there's just some amount of space in between them. So the way you would say that in regular expression is I put a plus to the right of that \S, and that means, yeah, 1 or more, that element repeats. There's just 1 or more of those. And I'll do it with this one as well. Oops. So if I hit return there, so now that matches. So adding the plus and the star, I mean, I'll do a bunch of examples with these, but this makes the language really, this is exactly what we want to start matching more complicated patterns. Also, remember how I was saying how per character, regular expressions, I think it's like pretty much the densest language that any normal person would use. And like, look at that little bit of code, right? I mean, that really means something, right? Every character in the order, I mean, it's all really pretty significant. So I was about to say it's going to get worse, but what I meant to say is it's about to get even more interesting. Whenever a professor uses the word interesting, you always know you're in big trouble. All right, so I want to use this plus thing a little bit. So let's say I'm looking for, I've got this random text, and I'm looking for a colon, and then let's say a word character. Here, I'll use kitten instead, and there's some more text here. Now earlier, I'd said, oh, well, I kind of knew how long the word was, but that was kind of a ridiculous assumption. The more typical way to do this would be, I'd say, well, there's a colon, and I'll say, and then there's just some number of word characters. So I would write that as \W plus. That's a much more typical way, right? Like there's a quote or a colon. There's something that sort of starts, and then you're like, yeah, whatever. Then just take all the word characters from there. So if I write it that way, then it just picks out the kitten part. So that is this is beginning to look a little more the way these things actually work. Yeah, so the space is not a word character. That's what's making it stop there. So, and actually there was the question before, like, does it include digits? So what if it was like kitten 1 2 3? That still works. But if I kitten 1 2 3, and at some point I have to add a character, like let's say ampersand, then it stops at the ampersand. So this is the thing. So what the plus does is the plus is greedy. It goes as far as it can, and then it stops. So just kind of the mnemonic for regular expressions is it finds the leftmost solution, the first one, and the largest solution. So the plus, to the extent that there's a plus and a star, it just goes as far as it can. Yeah, question?
So period plus would take you all the way to the end of the line.
Oh, yeah, so the question is period plus would take you, well, it's not a question. It's actually a suggestion. So, but I'm going to phrase it as a question. What if I said period plus? And the answer is, like, yeah, it just goes all the way to the end. Right? So period matches, dot, ampersand, everything. Okay, except for new line. All righty. Yeah, question?
When you say largest, do you mean that if you say kitten 1 2 3 1 2 3, it will find a whole
So if I say, you mean here, if I say kitten 1 2 3 1 2 3? And I'll go back to this is backslash W plus. Okay. What do you think that's going to do? All right, yeah. So it'll go through the both 1, 2, 3s, and then that'll stop because the space is not a word character, but digits 0 through 9 are word characters. I mean, I understand it's made a little bit of abuse of the word word, right? I mean, to a normal person, it doesn't seem like a word character, but compared to like ampersand, it's a word character. All right. So one more code I'm going to show you, which I'll just type in here, is backslash uppercase S is a non-white space character. It's kind of like the opposite, and I'm a little saddened that whoever designed regular expressions chose to have uppercase and lowercase mean something different because it just makes it a little bit confusing. But backslash uppercase S is really pretty darn handy. So let's say, for example, I knew that it was kitten 1, 2, 3 and A equals 1, 2, 3 ampersand, yada, whatever. It's all this junk, and then there's a space. And I want to write a regular expression that picks up all of that. And but I don't know. It's not just word characters. I mean, it includes all sorts of stuff. But at least there's not spaces in it. And a common pattern is if I write that as there's a colon, and then there's just some series of non-white space characters, and then it'll just sort of terminate with the first white space character. So that just catches the whole thing, even though like Lord knows what sort of characters in there. So just as a practical matter, that's a backslash uppercase S is a potentially handy way to catch that stuff. Alrighty. So let me show you. So those are all the plus, the star, and those backslash codes. Those are the ones I want to build on. Now, what I'm going to do, so far my examples have been like a little bit limited. I want to now I want to do an example with emails. I'm going to kind of build it up and hopefully show you pretty practical patterns you can use. All right. So I'm going to make up some text here. I'll keep the blah. So let's say we're looking for nick.p@gmail.com, and then there's some more junky text, and I mean, there's an at sign just by itself. I'll just leave it like that for now. All right, so the problem I want to solve is pulling email. I want to imagine I've got this big body of text, and I want to pull email addresses out of it using regular expressions. I'm going to try. First, I'm going to try to write this as backslash W plus, and then there's an at sign, and then there's backslash W plus. It's a kind of plausible first shot at this. So if we run that, so what's happened here? So what's happened is, well, it finds there's the at sign. It's the P, but it can't go further left than that because the dot does not count as a backslash W character. And then likewise, it gets Gmail over here, but then it's confounded by that dot. So what I want to say, hit the up arrow, is I want to sort of expand. Well, it's not just word characters. Really, it's word characters plus some other stuff. So regular expressions, there's this very old syntax for indicating a set of characters. And it's going to use the square brackets. So inside of the square brackets, I can put, well, here's the set of characters that I'm going to allow here. And actually, the backslash W works inside of the square bracket because it's just such a common case. So what I want to say here is, well, backslash W or let's say dot. And then let's say, well, I'll just leave it at that. So the question, yes, it's a very natural question. That dot, it happens you don't have to backslash that one. That it understands that the dot inside of the square bracket is just a dot.
Backslash W included in dot?
No, so backslash W word characters is just A through Z, 0 through 9. It does not. Oh, no, I'm sorry. That dot there means literally a dot. It doesn't match any character.
Because it's in a square bracket.
Because it's in a square bracket. It means literally a dot. I mean, it's sort of what's going on here. I mean, you can work on your PhD in the textual something like that. It's kind of levels of quoting is kind of what's going on here, and it is a necessary complexity to talk about this kind of thing. All right, so let's just see what that does. All right, so you can see, you can sort of see that. So that picks up its word character, and then it stops at this space essentially, right? So it's not really a dot. I'm sorry, it's not a regular expression dot. It's just a regular dot. All right, so I'm going to fix the other side as well. So I'll put a square bracket over here, and I'll put the dot in there. Oops. And then the plus goes outside, right? I'm saying that whole set repeats. All right, so that's kind of fixed it. So the square brackets is probably the most convenient way. If there's some set of characters that you're looking for, you can kind of build it up and say, well, yeah, here's what I'm looking for. What if I had a dot before Nick? I'm sorry, dot, you mean like he?
Text.
Oh, it would pick it up. I mean, we've said, we've said to the left of the @ sign, just, as many of these as possible. So it'll, now let me phrase it anyway. Suppose we wanted to say that the first character can't be a dot. It must be a word character. Can you think of a way in the pattern we could say that? Yeah, what I'm going to do is I could have a single \w. Say there must be a word character, and then it's followed by one or more of the thing that includes the dot. That'd be it. Although then to be super, I think, really clear, then we should change that one to a star. Right? Then there must be one word character, and there's 0 more of this pattern.
In other words, once you're inside the brackets, the order doesn't matter. It's any other.
Yeah, that's right. Yeah, so exactly. Yeah, so once you're inside the brackets, the order doesn't matter. Or I should try to use the word set. It's a set of characters. All right, so let's try that. Yeah, so then that refines the term. All right, so anyway, you begin to, yes, it is a somewhat bottomless topic. I mean, there's, but I'm going to hopefully show you stuff that's still pretty useful. All right, so I've got my emails example. So that's the first thing. So that's just using group, right? All I've been doing there is just using group. So now what I'd like to show you is I'm going to stop using my find function. I'm going to start doing this raw here. And what I'd like to do is I want to imagine that I want to pick out the username and the host name separately. I want to sort of pick those out. And so I'll just go back here. I'll just change this to m equals re.search. So I'm just doing it manually again. And you can do this. I'm going to change this back to just the regular way here. By putting parentheses in the regular expression around the parts that you care about. Now, the way I'm doing it here, the parentheses are not changing what it's going to match. I'm just kind of putting in this markup of saying, well, these are the 2 parts that I care about. And here, I'll get rid of this dot. So if I do that, right, so I've put parens around the part that matches the username and parens around the part that matches the host, and the @ sign I don't care about. So now I've done this. If we look at m, it's a match object. If I say m.group, it's the whole thing, just like we've always been doing. But there's also a form of the group where you pass it a number. So if I say m.group1, that's now just the username part. And the 1 refers to the first set of parentheses. So if you count the parentheses, and it goes by the left parenthesis, because you could actually nest them. So the group 1 refers to the leftmost parenthesis, which if you look up here, is like, yeah, that's that guy. And then m.group, oops, you can just guess. Group 2, that's now the host name. So the way this is going to work for real, really solving problems with regular expressions is a lot of times you'll write a regular expression for the thing you're kind of looking for, right? Well, I'm looking for a URL or an IP address or something. And then you'll maybe put parens in to say, and here's the part that I want to extract. Then you'll call re.search, you'll get this match object, and then you'll use group 1, group 2, whatever to just kind of pull. It's already parsed it for you. You'll just pull out the parts that you want as text and then process from there. Yeah, question.
So if I put a plus or a star after one of these, say after the first parentheses, and it matches that twice, is that group 1 and then group 2, or is it still group?
Yeah. So the question is if there's a plus after the parenthesis, does that change how the group numbering works? And the answer is no. The group numbering is based on just statically looking at the pattern as an unchanging thing and just counting the left parentheses from going from left to right. So that is the shortest answer I can give you there. All righty. So I've got so re.search is my my second favorite Python regular expression function. My absolute favorite one, actually, let me make my data a little more complicated here. I'll also add a foo at bar. My absolute favorite regular expression function is called find all. So I'll just say find all here. And what find all is going to do is I've just still got a pattern. And now I've just changed my text to just, I put a second email address in there. What find all does is it just takes the pattern, and rather than just stopping at the first match, it just continues, and it just finds all of the matches, and it returns them to you. It returns to you essentially the dot group, right? The whole text, just in a Python list as strings. So, for example, we talked about for a file how you could just say f.read to get the entire text as one string. So a pattern I always enjoy, because it just saves me so much work, is I just call f.read, and I pass that in as the second argument to a findall. I just feed the entire file into an re.findall. I have a pattern. I just let it rip through the entire text, skip new lines, whatever. All that stuff it just handles, and it just pulls out the things I want and just returns them to me as a Python list. And then you could write a for loop or all the stuff we were doing yesterday. Now you can just process this list. So that's really how I use this stuff. So in this case, so notice I took the parentheses out. So I just left this as a simple pattern. So I just got this list of matches. There's this one other variation I can do here. What do you suppose is going to happen if I put the parens back in? I'm like, well, this is, it's not really it's a pattern, but it has this grouping in it. And yeah, tuples. Yeah, what it's going to do is if there are parentheses in there, instead of just returning the whole match, it says, oh, well, there's two parens. I'm going to return tuples length 2. So each tuple represents a single match, and then the tuple just has the groups in there. So that, yeah, you can see where this could be pretty handy. If you've got some big file and you just want to kind of, there's some part about it you care about, you just want to rip it out as lazily as possible. So re.findall works really well for that. Excuse me?
You lose the full match.
Yeah, or I would say the suggestion is you lose the format. I'd say, well, the regular expression is narrowing. You get to say what you want to keep. And so if you want to keep more, write the regular expression bigger, to keep more. All right. So that's not hard to imagine how it's going to be easy for me to work that in to doing stuff later on. So I'll just mention there are some optional arguments that you can add sort of here as a third option to the regular expression. And what I'm going to actually do, I'm going to do a dir on re. So that's the re module, and I just said, oh yeah, hey, what are the symbols in here? So these are some constants. So if you add the constant ignore case to your, this works on .search or .findall. That means that it'll consider upper and lowercase the same. So a lowercase I will match an uppercase I and vice versa. You can do the .all. I had said that the dot matches any character except for new line, and that's kind of a historical thing because the processing tended to go line by line. If you add the .all flag, then the dot will match new line as well. And so you're right, because right now if you use dot, your pattern can't span more than one line. Although if you use \s where you think there's a new line, that'll span a line, but the dot will not go over a line. So if you add .all, you can turn off that behavior, and dot will just truly match anything. So if you were to say .star with nothing else, it would just go to the end of the file. So there's some other, those are I think the most common ones to use there.
Like the constants you got just at the end of like.
Yeah. So I'll give you an example. So the way you would use those constants is it's as a third argument. So you would say re ignore case or whatever as the last argument there. All right. And so the the handouts for today. The first one. If you didn't get one, you can get one in a second. There's a nice an explanation of regular expressions, and it shows the syntax and a lot of the kind of stuff that I've been doing here. All right. So so I think we're ready for an exercise. So the exercises today are going to be a little bit bigger. There's 3 of them I'd like to do today, and kind of incorporate all this sort of stuff. So let me demo this first one. So. This first one is going to involve a brief foray into a little understood part of the government called the Social Security Administration. Now, the Social Security Administration, in my life experience, is in charge of putting certain fields on everyone's paycheck that no normal person understands, and it just causes you to just not know what's going on. But they do this other thing. If you do a Google search for Social Security Administration baby names, they do this thing where they keep track of what the popular baby names are for babies born in that year. And they've been doing it actually for 100 years. So you could look at 1900, 1950, whatever. You can just see what's. And it turns out for baby names, there's sort of there's a popularity of it. There's sort of names kind of ebb and flow. So I look at this and I see assignment idea. So let's go to, oh, I don't know, 1980. I'm not even going to try and think about when you guys were all born. Yeah, okay. And let's just go with like, I don't know, the top 1,000. So we get this like, you look at this and you're just thinking like TR, TD, that kind of thing. Yeah, good thinking. All right, so here's just for 1980, the list of baby names. And what this is saying is that for boy children, Michael was the most popular name. And then next most popular was Christopher, Jason, David, so on. And over here we have Jennifer, number 1, Amanda, number 2, so on. And it just goes down to like, here we have, Bobby, Emil, Jermaine, Craig with a K, down to the, the less popular names. All right, so what I would like to do, going back to Python here, let's see where I have it. Okay. So I'm going to go into day 2 here. And there's this directory baby names. So if I look inside of here, I'm going to look at baby 1990. I've pulled this I've just sort of copied and cleaned up just a teeny bit the text from the Social Security Administration site. But this is very realistic. Okay, well there's some poorly written CSS and whatever. And then eventually there's here's the H1. And then here's a table, blah, blah, blah. And at some point it's going to say, oh yeah, here we go. So here's the H3. This is popularity in 1990, or as I like to think of it as popularity in \d, \d, \d. And then there's some whatever junk you want to skip, and there's a TR. And then here, there's the TR. I mean, if you don't know HTML, but whatever, that's the HTML for that first row. So it says TR, TD, and then there's the number 1. And then there's some more TD stuff, and then there's Michael, and then there's Jessica, and then here's row 2, and so on. And it just goes on like, there's all the data. This is beginning to look like an actual problem. All right, so the first thing that I want your baby names program to do is given a file like baby1990.html, and I'm going to pipe this into more. What I want you to do is I want you to rip through that entire file. I want you to figure out what year it represents. I want you to pull out all the names and all the ranks. I want you to organize it so that you can then produce a printout that's just in alphabetical order by name. So just as shown here. So you say, so the first you print the year, and then I want to see Aaron 34, Abby 42, and so on. So you're just showing alphabetical list. Here's what all the names are. So that'll get us through the. Yeah, so what's going to happen, there's the strange case, but sometimes a name will appear as both male and female. And I'm not making any distinction, male from female. So in that case, I want you to give it the more popular, essentially the smaller number, whatever the smaller number is. All right. So let me talk. I'm going to go back to Python for just a second. There's something I mentioned, I think, maybe very briefly yesterday, but it's about to come up, which is we did file opening, right? So f is equal to open of some file name. So I'll remind you, if you want to write a file, if you want to do it for writing, then for that second argument, you pass a W. So yesterday we just did R. We just read the file, so that's fine. So you put a W there for writing, and in that case, then probably the simplest way to write to the file is then it has a .write, and then you could just have whatever kind of text you want in there. And then so you've got to be careful. You can zero out a file here, but it'll write that text. And so this is in the handout as well, but that's about to come up. All right, so part A is I want you to just pull out all the names. Right? Use a regular expression, find all, maybe a dictionary. I mean, just total regular work. So for part B, what I'm going to do is there's an option called -- summary file. And I'm going to run this on a star, or I'm going to say baby star.html. In that case, I want you to produce no output. What did that just do? When the --summary file option is given, what I want you to do, and notice in this case I ran it on baby star. So I ran it on all of the baby files, right? So the shell just expands that. So in that case, argv is going to be all of them. If the -- summary file flag is given, what I want you to do is for each file, I want you to read it, and then I want you to create a new file with the same file name but ending in .summary. And then I want you to take that output that we were printing to the screen earlier, and I want you to write it to that file. Now, there's a little bit of a trick here, which is to show, like, so for example, when you have a low-level function, you don't necessarily want it to print to standard output directly. You want to have a function that, given a file, returns to you, say, a Python list or a dictionary or something. And then the code that got that data structure can choose what to do with it. It can either print it to standard out, or it could print it to a file. So you've got that latitude. I'm sorry, certainly that technique will come up trying to solve this. All right, so once you've got that, then you can do this something kind of neat. So now I've got these .summary files, and what's happened is, because I've done them over a decade, you can sort of see patterns, right? So this is going in increasing order by year. So my name, in the Nick form at least, was like, not looking so good, and it's getting worse. Now, there's a lot of interesting data in here. So you can, interesting data makes for fun assignments, I think. Here's probably the funniest part of this thing, is Trinity. And the question is, in what year did the movie The Matrix come out? And whatever. Yeah, there's another PhD thesis you could do here. Sort of like, well, maybe The Matrix was reacting to a social phenomenon, or is the other way around, and it's all very complicated.
The book Freakonomics describes the whole baby.
Yeah, the Freakonomics comes in. There was a New York Times Magazine article about it. Anyway, so it just turns out there's this entire topic of baby name popularity that's sort of very interesting. And at least now you get to do the nitty-gritty work of actually pulling out that data. All right, so here's what I'd like you to do. Work on this, and then let's see, that'll get us to, and then have lunch. And I'd like you back here at, let's say, 12:45. All right, so a little bit of coding, a little bit of lunch, then back here. All right.